Hello everyone, today we are going to introduce the last topic of this unit. And this topic is more like to summarize the discussion we had about rigid motion, so which is called properties of rigid motion. And today we are going to look at this topic through a example, and we can discuss how do we answer those type of questions by using the properties of rigid motion. So before that, let's quickly review something we discussed about rigid motion. As we mentioned before, rigid motion is type of a transformation. They move the figure into different location. However, the most important thing is they do not change the size or the shape of the original picture. That's why we say rigid motion can produce congruent figures here. And as we mentioned before, the picture before the movement is called pre-image, and the one after the movement, which is called image. And we prefer to use that little comma in the corner to label them. For example, like this example, ABC is translated sliding to A prime, B prime, C prime. And we already discussed three types of the rigid motion, which are translation, reflection, and rotation. All three type of the transformation, the common feature is they do not change the size or the shape of the figures. So that's why we call rigid motion. Keyword here, rigid, is that keep everything the same. So let's check the example we are going to discuss today. So today we are going to look at this question here. You can definitely pause the video to check the question on your own and think about how do you answer this question. So question, the given information is we have a triangle ABC, as you can see on the right side, and triangle A prime, B prime, C prime is image of triangle ABC. So, and also the question asking us is triangle A prime, B prime, C prime congruent to triangle ABC? So that's a question. And also they also ask us to use the properties of rigid motion to explain your answer. So you can definitely pause the video to think about how do you answer this question and what's your understanding for this question. So whenever you talk about the congruence between triangles, probably the first reaction you are thinking is, can we use those 5 methods we discussed before? Yes, definitely you can. However, it doesn't apply to this situation because the question asking us use the properties of rigid motion to explain your answer. So instead of figuring SAS, SSS, those kind of methods, we need to think what kind of rigid motion I can apply to triangle ABC in order then to get the new location of A prime, B prime, C prime. So that's something we are going to do. So what do we do here? Whenever I see this kind of question, the very first thing is I check like single point to test my theory. And then I use the same idea to apply to another point to test, oh, is that correct or not? If this is right, then definitely that will be the method. So let's see. So the first one we look at this is the A is on the right side, A prime is on the left side, and for B same thing, is totally on the upside on the opposite side. Sorry. So this actually indicates there's a reflection over there. So let's check. Let's use A to test our theory. So from A to y-axis is like 3 units away. For A prime, you notice that it's on the same location here, is also 3 units away. So first it seems that reflection is happening. And then if we notice the A, it's definitely not, so that's a temporary position here. In order to get A prime, I need to move down 3 units. So it's like a translate, right? As we mentioned, it's just translate. So it seems that we reflect across y-axis and then translate 3 units down. That's what happened to A prime. So let's check, can we use the same idea to get the C prime? So C is also 1 unit away, and then C prime is also 1 unit away from y-axis. So reflection, check. And then we notice that for C prime, I move down 3 units down. I can also get C prime. So it seems that it works. So The translation, so the rigid motion happening here is first reflect across a y-axis and then translate 3 units down. So some student might wonder, what if I use different kind of rigid motion to get the same answer? Then you are right, because the key idea is sometimes the order of the rigid motion can be different, but we still can get the same result. So definitely try that to see that works for you. Now let's summarize the final answer here. So based on the discussion we just had, yes, they're congruent. That's our conclusion. That's our conclusion. So now the most important part is how do we explain by using the properties of rigid motion. So for first, we need to indicate what happened here. Triangle ABC, as we mentioned, is reflected across, y-axis, then translated 3 units down to be triangle A prime, B prime, C prime. So what do we mention here? We indicate reflection happening here, translation happening here. So, and the most important part is we need to indicate reflection and translation are rigid motion. Which keep the size and the shape of the figures. Sorry. That's why, you can be more detailed about that. That's why they're congruent. See, we use a property of rigid motion to produce the congruent figures, and right this time we use a different perspective to see congruence instead of saying what we mentioned before, like SSS, SAS, but this time we actually use a property as a rigid motion to produce a congruent figure. So this is how do we look at rigid motion through the different perspective. Okay, so that's the example I want to share with you. I hope this example will help you to better understanding this topic, and also I hope this video is helpful. Thank you so much for watching this video. If you have any questions, definitely do not hesitate to email us. Okay, thank you so much. See you soon, everyone.